Have you ever stopped to think about what actually happens the moment you hit send on an email or when you type in a web address? There's this whole hidden, super organized world that just springs into action. And today, we're going to pull back the curtain on the invisible frameworks that make our digital lives possible. All right, let's get into it. So here's our game plan. We're going to start with the big problem that needed solving. Then we'll look at the two big models that came out of it, the theoretical OSI model and the practical TCP/IP model. We'll put them side by side to see how they relate, and then we'll follow a piece of your data on its wild ride across the internet. Okay, first things first, let's really understand the massive challenge that's at the heart of all of this. I mean, seriously, think about it. You've got an iPhone made by Apple in California trying to connect to a web server running Linux in South Korea, which is talking to a Windows gaming PC in Germany. They're all made by different companies, running different software. How in the world do they speak a common language? Well, the answer's pretty simple in concept. They all agree to follow the same rulebook. This shared set of rules is called a reference model, and it's basically the universal translator for machines. It's the secret sauce that allows all these different technologies to play nicely together. So let's dive into the first major attempt at writing this universal rulebook, the OSI model. The OSI model, which stands for Open Systems Interconnection, is this big, beautiful 7-layer framework. Now, here's the really important thing to get. It's not a strict protocol. Think of it less like a set of laws and more like an architect's blueprint. It's the perfect idealized guide for understanding how any network should work, in theory. And here it is, the famous 7-layer stack. You can see it starts at the bottom with the really physical stuff, the cables and hardware, and it moves all the way up to the top, to the apps that you and I actually use every day. Now, trying to memorize all 7 layers in order can be a pain, but thankfully, some clever network engineers came up with a really easy way to remember them from the bottom up. Just remember this sentence. Please do not throw sausage pizza away. Physical, data link, network, transport, session, presentation, application. See, you'll never forget it now. So how does your data actually use these layers? Well, as your message travels down the stack, from the top layer to the bottom, each layer wraps it in a little bit of extra information. It's kind of like putting a letter in an envelope, and then putting that envelope in a small box, and then that box in a bigger one. This whole process is called encapsulation. And you can see that journey right here. Your message starts as just, data. The transport layer bundles that into a segment. The network layer pops that into a packet. The data link layer puts a wrapper on that and calls it a frame. And finally, the physical layer chops it all up into bits, just ones and zeros, ready to fly across the network. Let's start at the very bottom, layer 1, the physical layer. This is where the rubber meets the road, literally. We're talking about the actual hardware, the copper wires, the fiber optic cables, the Wi-Fi radio waves. Its only job is to turn all that data into ones and zeros, or bits, and send them out. Okay, one step up at layer 2, you've got the data link layer. Now this layer is all about getting data between two devices that are on the same local network. Think of it like the neighborhood mailman. It organizes those bits into neat little packages called frames and uses a physical MAC address, which is like a unique serial number for your device, to make sure it gets to the right house on your street. And this is where things get really cool. Layer 3. The network layer. If layer 2 was the local mailman, layer 3 is the entire global shipping network. This layer takes data and puts it into packets, then stamps it with a logical address, your IP address, so it can travel across thousands of different networks all over the world to get to its final destination. This is what makes the internet possible. So that's the perfect 7-layer theory. But here's the plot twist. It's not actually what we use to run the internet today. For that, we need to talk about the TCP/IP model. The TCP/IP model is the lean, mean, practical cousin of the OSI model. It's a much more condensed 4-layer system, and it is the actual standard that powers pretty much the entire internet you're using right now. It's got 4 layers: application, transport, internet, and network interface. So, how does that beautiful 7-layer blueprint match up with the 4-layer reality that we actually use? Well, this chart makes it super clear. You can see how the TCP/IP model basically just combines a few layers. The top 3 OSI layers, application, presentation, and session, they all get squished together into one big application layer in TCP/IP. And down at the bottom, the physical and data link layers are merged into the network interface layer. It's just a more streamlined, practical approach. All right, this brings us to the final and the most important part of all this: why both of these models actually matter when we talk about your data's journey. And that leads us to the million-dollar question, right? If the entire internet runs on the 4-layer TCP/IP model, why on earth do we even bother learning the 7-layer OSI model? Is it just a history lesson? No, not at all. And here's the key takeaway. The OSI model is the ultimate troubleshooting guide because it's so specific and breaks things down into 7 distinct steps. When something goes wrong, a network engineer can use it like a checklist. Is the internet out? Well, is the cable plugged in? That's a layer 1 problem. Can't get to Google? Maybe it's a routing issue. That's layer 3. The OSI model gives them a precise map to find exactly where the problem is. So I'll leave you with this final thought. The next time you send a quick email or load up a web page, just for a second, try to picture that incredible journey. Your data getting wrapped up, traveling down the layers, turned into flashes of light or electricity, zipping across the globe, and doing the entire thing in reverse, all in less than the blink of an eye. It's pretty amazing when you think about it.